Hi guys! Welcome to your second and last lesson in Topic 6. As a reminder, if you're following along in the textbook, I'm folding together the Topic 6 lessons by 2. So in this class, we're actually going to deal with 2 of the subtopics from the textbook. We're looking at both photochemical smog and acid deposition. So let's get started. The first thing that we are going to talk about is pollutants in the atmosphere in a general way. So when you need to define atmospheric pollution, you can talk about both primary pollutants, you can talk about both primary pollutants, which are emitted directly from a process, so stuff like carbon dioxide, sulfur dioxide, NOx, which is basically a substitution for any kind of nitrous oxide or nitric oxide. This X means that like any number could go there. And PM, which is particulate matter. So those are all things that are active as pollutants right on emission. You can also talk about secondary pollutants, and those are formed when primary pollutants undergo reactions with other chemicals already present. They can also undergo reactions with sunlight, and in that case, you call them photochemical secondary pollutants. And the 2 examples that we look at the most here are tropospheric ozone and smog. And remember, I said that there were 2 kinds of ozone in our atmosphere. Tropospheric ozone is the bad ozone. And there's a little diagram of how it's formed down here. When you have nitrous oxide pollution, either a nitric oxide or a nitrogen dioxide in the atmosphere, and it reacts with sunlight, it breaks down into NO, nitric oxide, and an extra oxygen atom. That extra oxygen atom can combine with an oxygen molecule, the same way that it does in the stratosphere to form the ozone layer. But in the troposphere, this ozone is harmful for a few different reasons, not least of which is that it is one of the primary components of photochemical smog, which we'll get into in just a second. But first, let's look at some of the possible effects of all of these kinds of pollutants. So in terms of primary pollutants, carbon oxides and nitrogen oxides are greenhouse gases. They are also instrumental in the formation of smog. Particulate matter is stuff that, like the stuff that you can see that's in air pollution, particles that are floating around. And those can be harmful because if they're composed of dangerous substances, they can cause cancer. They also obviously cause respiratory problems as you're inhaling foreign objects into your respiratory system. And if they land on plants, they can reduce plant productivity because it limits the amount of sunlight that the plants can get. Ozone has some really significant effects all on its own. The first is that it is a very strong greenhouse gas. The second is that it's a very damaging substance, so it can degrade chlorophyll and lessen the availability of plants to do photosynthesis. It can cause breathing problems. It can cause damage to materials. But maybe most significantly, tropospheric ozone is a major component of photochemical smog. So photochemical smog is a mix of ozone, nitrogen oxides, which is what gives it this gross brown color that you usually associate. Lots of other trace pollutants, like up to 100 other things, can go in photochemical smog, and most importantly, sunlight. So because it's a photochemical substance, its peak formation is in the late afternoon when the sunlight is strongest. And the effects and the existence of photochemical smog worsen with thermal inversion. So if there's like a layer of hot air sitting over a city, it can trap photochemical smog below it. Also, it worsens when there is not a lot of wind to blow the photochemical smog out of the area, and when there's high fossil fuel emissions because fossil fuels give off these nitrogen oxides. Photochemical smog is getting to be a more and more serious problem in our world. Some cities where the smog is really bad are LA, Rio de Janeiro, Beijing, and Mexico City. People also talk about Athens and Greece as having bad photochemical smog, and Santiago in Chile. The health effects of photochemical smog for human populations are really serious, because the effects of all the component pollutants are worsened when they're put together. So photochemical smog is one of the reasons why a lot of cities have air quality warnings, where you're not even supposed to go outside if photochemical smog conditions are bad enough in a given day. And again, that is dependent on the weather. But when we look at strategies for reducing smog, we're dealing with our same 3 tiers of strategy that we always do: altering human activity, regulating the release, and cleaning up and restoring the ecosystems where it is happening. There are some examples of actions over here. Obviously, for human activity, if we drove less, that would be really helpful. The thing that would probably drive people the most to do that is if there was some kind of a government regulation or tax on driving, which they're starting to do in some cities. Like London has a pretty significant driving tax if you want to be in the center of the city. And also the regulated use of some technologies like catalytic converters has been really helpful in scrubbing nitrogen oxide compounds out of the air and lessening the development of photochemical smog. In terms of cleanup and restoration, afforestation, or creating forests and green spaces, is not a significant help, but something that can be done to try to combat photochemical smog, because it acts as a sink for carbon dioxide compounds that would otherwise go into the photochemical smog compound. But photochemical smog is a serious problem in our world, and you should feel comfortable evaluating these solutions. So remember, an evaluation means that you are giving the benefits and the drawbacks of each level of pollution management, and this is something that you'll get some practice with in the homework assignment, so keep that in your mind. The next thing that we are going to look at is acid deposition, which is an atmospheric pollution concern, but behaves in a way that is a little bit different from photochemical smog. So acid deposition is when acid or acidic substances coming from the air form secondary pollutants when they mix with water, like sulfuric or nitric acids, and they can be deposited or dropped into the biosphere environment 2 different ways. Wet deposition is when these substances mix with water and form precipitation. Dry deposition is when particulate pollution that is acidic comes and just rains down on an area. And acid deposition has a lot of serious effects. You can see weakened plant growth in forests where either wet or dry deposition has happened. It's very damaging to lichens, which are an indicator species. You might remember talking about those back in topic 2. And when you start to damage an indicator species, you know that you're causing a serious problem somewhere in the environment. You can also change the pH of both land-based and water-based systems. If you do that in a water-based system, it obviously affects the aquatic life that is not adjusted to the new pH. Over land, the bigger concern is that acid deposition will lead to leaching of nutrients and increased solubility of metal ions. So if you have a soil-based system and there's all of these acidic pollutants being filtered down through the soil, those pollutants will grab on to nutrients to try to stabilize themselves and leach them down into the soil. You can also see acid deposition as damaging to buildings, especially limestone buildings, because they basically dissolve when strong acids hit them. And in that way, it's sort of a threat to some of our culture as a human society. And then when you have really dry particulate deposition and people inhale that, it is damaging to human or other animal respiratory systems. And there are some well-documented examples of acid deposition. Here in this table, you have region of origin, region of effect. One of the complicated things about this problem with acid deposition is it's controlled by the wind. So you can produce a pollutant in somewhere like Germany and have the wind blow the deposition from that pollutant over the Scandinavian countries like Norway and damage forests and economic systems that aren't related to where the pollutant was created. So Because of that, there has been a specific interest in the legislative tier of solutions to acid deposition. The most significant piece of legislation was in 1979, the UN Convention on Long-Range Transboundary Air Pollution. The problem with this, of course, is that it is a little bit hard to prove where the air pollution is coming from. It's a non-point source by the time it gets up into the atmosphere. But internationally, people are trying to have some kind of a system to regulate pollutants country by country. And that's where things like the Clean Air Act of 1995 in the United States come in. It wasn't necessarily that they were concerned about the effect on Canada, but they were concerned about the general effects of the pollutants that they were using in their factory emissions. So that pretty much ties up the different kinds of atmospheric pollution that we are going to look at. For your homework, you are going to do something a little bit new. If you're following along in the textbook, you're reading 6.3 and 6.4, which is pages 286 to 299. And for your comprehension question, we are going to do paper 2, section B, but not just part C. You are going to try a whole 20-point response. And the responses are usually broken up like this. Part A is worth 4 points. Part B is worth 7 points, and Part C is the essay-style response that is worth 9 points. Parts A and B are graded just point by point on a mark scheme, just for your information. So give all that a try, and when you are ready, you can move on to the review video to check your work. And I will see you there.